Now here in 6.5, we're going to be dealing with special cases. Now, on this binomial, we're going to call this the difference of the squares to begin with. 6.5, I have to have a difference, and then before and after the minus. So difference obviously means minus. Before and after the minus, it has to be to the squared. So let me rewrite this as p squared minus 4 squared, right? 16 is 4 squared. So I have p squared minus 4 squared. Now, the way this thing breaks down, when I factor this, is going to be p minus 4 and p plus 4. Once again, the order of the parentheses does not matter. Make sure it's a minus in between and you have squares on both sides. Now, example B, we cannot do this on example B because we do have a minus, but I cannot do the square root of 8. Right? It's not a simple number. So this cannot be simplified. X squared minus 8 is as simple as we can go. On example C, I cannot do it either. Even though I have a p squared and I have a 4 squared, I can't do it because I have a plus in between it. I need to have a minus in between. So p squared plus 16 is as simple as we can go. We cannot factor that one anymore. So once again, it has to be a minus in between and squares on both sides. Now, looking at this example, 25m squared, I can rewrite that as 5m all squared minus 4, I can write that as 2 squared. So I do have a difference of the squares. My factors are going to be 5m minus 2 and 5m plus 2. So again, the parentheses look the same. It's just that one of them has a minus, the other one has a plus. Looking at my example B, the first thing I can write this as 7z all squared minus 8 squared. So once again, try to rewrite this as the difference, so a minus in between, difference of the squares. My factoring is going to be 7z minus 8 and 7z plus 8. Cool. Now looking at my example C, the first term I can write this as 3x all squared minus 2z all squared. I have the difference of the squares, so my factoring of this will be 3x minus 2z and 3x plus 2z. So that's how we call this, that's what we call it, the difference of the squares. Now, factor more complex difference of the squares. All right, so let's take a look. First thing I gotta do, I'm gonna rewrite this as 9y all squared minus 6 squared. So I'm just gonna go 9y minus 6, 9y plus 6. Then we're like, wait, I can still factor something out of here. On the first group, I can factor a 3 out. So I'm going to have 3y minus 2. If I look at the second group, I can also factor 3 out. So I'm going to have 3y plus 2. So my factors are going to be 3y minus 2, 3y plus 2 for the parentheses. But now these numbers that I factor out on my answer, I'm going to write them as 9. Because I factor them out, I'm going to multiply them. So it's 9, 3y minus 2, and 3y plus 2. Another way we could have done this, let me come back over here. We have 81y squared minus 36. I could have taken the 9 out of it to begin with, and I would have gotten 9y squared minus 4. If you notice, 9y squared, that is 3y all squared minus 2 squared. So that would have given me my 3y plus 2, 3y minus 2, and obviously don't forget the 9 on the outside. So we call this a little more complex because even though it did look like a difference of the squares to begin with, it was difference of the squares. Once we separate it into two parentheses, we can still factor even more. Okay, let me take a look at my example B. P to the fourth, let me write that as p squared squared. All right, that's p to the fourth minus 6 squared. So I'm just going to factor it as p squared minus 6 and p squared plus 6. Okay. If here, see where I have the minus? If I could do difference of the squares here again, split this one into two more parentheses, so it will be 3 in total. We're going to see it right now here in example C. M fourth minus 16th, let me write that as m squared squared minus 4 squared. So that breaks down as m squared minus 4 and m squared plus 4. But I see that my first parentheses, m squared minus 4, that can be seen as m squared minus 2 squared. Right, I'm going to cancel it out. M squared minus 2 squared. So notice I have difference of the squares again. So from there, I'm going to have m plus 2, m minus 2, and then m squared plus 4. Once again, the first parentheses, I split it into two more. Obviously, this last parentheses is there. So if you have difference of the square, you guys can split it into more parentheses. All right, so that's the difference of the squares. Now, here, factor completely. I cannot think of a number that multiplied by itself equals 50, right? So it doesn't look like a squared. However, I can factor a greatest common factor out of here. If I divide both of them by 2, if I factor out the 2, I'm going to have 25r squared minus 16. Now, that parentheses looks like 5r squared minus 4 squared. Now the parentheses looks like a difference of the squares. So the parentheses itself will give me 5r minus 4, 5r plus 4, and obviously don't forget the 2 on the front. Notice how, I don't know if you noticed in the previous question, my first parentheses, I did the plus sign, and the second parentheses, I did the minus sign. It doesn't matter which one goes first, as long as one of the parentheses has a plus sign and the other parentheses has a minus sign. All right, let's take a look at B. Let me divide each of them by 3 to begin with, right? Because I cannot think of the square root of 27. So let me divide both of these by 3. So I have 9y squared minus 25. Now, the parentheses itself looks like 3y squared minus 5 squared. So my factor will be 3y minus 5, 3y plus 5. But don't forget the greatest common factor, that the 3 that we took out at the beginning. Don't forget it on your answer, though. So it's 3 times 3y minus 5 times 3y plus 5. So again, that's the difference of the square. So binomials can be tricky. Now, this one, let me do it two ways. X squared plus 10x plus 25. Let me do it two ways. One way, we could do it with the diamond. You know, that way we're familiar with. Two numbers that multiply equals 25. When we add them equals 10. I'm thinking of 5 and 5. All right, as a matter of fact, positive 5, positive 5. All right, because the leading coefficient is 1, I'm going to say I go x plus 5, x plus 5. So I'm just going to abbreviate this as x plus 5 squared. Right, the diamond will work. Every time we have a trinomial, the diamond will work. Now, one way we could have seen it was the leading coefficient is 1. Let me get the square root of it. Right, the square root of 1 is 1. Let me get the square root of the last number. The square root of 25 is 5. When I multiply these numbers, if it is, so 1 times 5, if it is equal to half of the middle number, then we have a perfect square. So once again, you get the square root of the first number, you get the square root of the last number, you multiply those two, and if it is equal to half of the middle term, you have a perfect square. So let me show you guys in a different example instead. Here, I can do the diamond and it will work. However, I'm going to do the square root of 1 is 1. The square root of 121 is 11. When I multiply these, 1 times 11, it is equal to half of 22. So I have a perfect square. I'm going to do x minus 11 all squared. I use this 1 here at the beginning. Notice I use that 11 there here at the end. This minus sign in front of the 22, that's what makes me put a minus sign there. If I had a plus sign instead, then I would have done x plus 11. Looking at this other question, the square root of 9 is 3. The square root of 16 is 4. When I multiply these, 3 times 4, that gives me half of 24. Right? 3 times 4 is half of 24. So I do have a perfect squared. And I'm going to do 3m to begin with. I'm going to do a 4 to end my perfect squared. And because of the minus sign, I'm going to put 3m minus 4 all squared. So you guys see how this thing is working? So that's why I double check with square roots at the beginning, square root at the end, just to make sure if I have what we call the perfect square. We call the perfect square because the parentheses happens to be the same. Now, we're going to do difference or sum of the cubes. Now, when it has a cubes, remember for squares, we needed to have a minus and it was the squares. But when it comes to cubes, we could have a minus in between or a plus in between. Let me rewrite this as m to the third minus 5 to the third. All right, so pay close attention how this one is done. The first parentheses, the first factored, ignore the cubes. So I'm just going to go m minus 5. That's going to be my first factor. My second factor is going to be a little long. Notice how my first parentheses, my first term is m. So squared your m. So m times m is going to give me m squared. Notice how it finishes with a negative 5. Squared that negative 5. So negative 5 times negative 5. I'm going to finish with a plus 25. So the beginning of the first parentheses, square it, and that's the beginning of the second parentheses. Square the ending of here, and that's how we end the second parentheses. Now, there's a middle term. Because my first parentheses have a minus sign, I'm going to go plus sign. I'm going to go the opposite. Then, multiply these two terms in the first parentheses. M times 5 will give me 5m. So once again, the first parentheses, just ignore the cubes. The second parentheses, squared the middle term, square the first term to find the beginning. Squared the last term to find the end. And then use opposite sign and then multiply your two terms for the middle. All right, let me use red for this other example. This thing, let me rewrite this as 2p all to the third minus 3 to the third. Because I want it to be different, so minus all the cubes. My first parentheses will be 2p minus 3, right? I'm ignoring the cubes. The second parentheses, I'm going to do 2p times 2p, right? I'm going to square the first term. 2p times 2p will give me 4p squared. I know at the end of the parentheses, I square the second one. Negative 3 times negative 3, that gives me plus 9. Now, for the middle term, first parenthesis has a minus, so I do plus. I will always go opposite sign. And then I multiply these two terms. 2p times 3, that gives me 6p. So, matter of fact, when it comes to the signs, the first sign is going to be the same as we have. The second sign will be the opposite. So notice I changed the sign. Now the last sign will always be positive. So if you guys remember the word soap, you guys will remember your signs. Same, opposite, always positive. That happens whether we have a minus in between the cubes or we have a plus in between the cubes, because it works with the pluses as well. Let's take a look at the plus. Let me rewrite this as k to the third plus 3 to the third. So my parentheses, my first parentheses will be k plus 3. On the second parentheses, I'm going to start with k squared because I squared the first term. I'm going to finish with a plus 9 because I squared the last term. Now for the middle term, I do opposite sign, right? Instead of plus, I write minus, and then multiply those two. K times 3 will give me 3k. Okay?